Tonight's video is on comparing fractions. In order to compare fractions to see which one is greater or which one is less, we need to have the same denominator for both fractions. So let's look at our first pair of fractions, 2/3 and 6/10. Well, let's just get a common denominator, and it doesn't have to be the least common denominator. And the easiest way to get a common denominator is multiply each denominator by each other. So multiply 3 times 10 and multiply 10 times 3. Now, since we don't want to change the actual value of the fraction, we need to multiply the numerators of each fraction by the same amount. And when we do that, in effect, what we're multiplying by is a giant 1. So if I multiply 2/3 by 10 over 10, well, 10 over 10 is the same as 1. If I multiply 6 over 10 by 3 over 3, 3 over 3 is the same as 1. So anytime you multiply a number by 1, you don't change its value. Okay? So here, we're multiplying by these giant 1s just so we can get a common denominator and compare. So 2/3 multiplied by 10 over 10 will give us the fraction 20 over 30. And 6 over 10 times 3 over 3 will give us the fraction 18 over 30. And so now we can see which fraction is greater. 20 over 30 is greater than 18 over 30, therefore 2/3 must be greater than 6/10. All right, let's go ahead and erase this. I didn't give myself enough room, so I'm going to erase that so we can do the next set. Okay, so let's multiply each denominator by the other, and then multiply the numerator by the same amount. So again, we're multiplying by a giant 1. The first fraction, 1/4, becomes 9 over 36. The next fraction, 2/9, becomes 8 over 36. So we can see that 9 over 6 is greater than 8 over 36, so 1/4 is greater than 2/9. Alright, so you can see that both these examples, if you just took a quick look at each fraction, 6/10 looks like it was bigger than 2/3, and 2/9 looks like it's bigger than 1/4, but actually they're not. Okay, so go ahead and pause your video and do the next two examples. Welcome back from pausing the video. 3/8 and 1/2. Alright, let's compare. And we can multiply each denominator by each other. And the same for the numerator. So again, we're multiplying by the giant 1. The first fraction, 3/8 times 2 over 2, becomes 6 over 16. The next fraction, 1/2, becomes 8 over 16. So in this case, 3/8 is less than 1/2. The next example, let's multiply 9 times 6 and 6 times 9 and do the same in the numerators. So we're multiplying by that giant 1. The first fraction, 7/9, becomes 42 over 54. And then 5 over 6 times 9 over 9, that's 45 over 54. So we can see the second fraction is greater than the first one. 5/6 is greater than 7/9. Okay, so how'd you do? Alright, now before we go to the next set of examples, going back to the first one, 3/8 and 1/2. Now in that instance, I could have recognized that 2 goes evenly into 8. So I could have left 3/8 the way it is and multiplied 1/2 by 4/4 and made it into 4/8, and that also would allow me to compare. So it really doesn't matter as long as we have the same denominators where we can compare each fraction. All right, here's a couple more. Go ahead and pause your video and then restart to check your answer. Welcome back from pausing the video. So our first set of fractions, if we look and see that 2 goes evenly into 10, we can leave 5/10 alone and just multiply 2 times 5 and 1 times 5, which is a giant 1, and that would make this equal to 5/10. So here we can see that in this case, both fractions are equal. 5/10 is equal to 1/2. Okay, the second set of fractions, if we recognize that 5 goes evenly into 15, we can multiply by 3/3, which is a giant 1, and that would make the fraction, that would make the fraction 12/15. And now I can see that that is less than 13/15. So 13/15 is greater than 4/5. Okay? All right, well, that's all for tonight. Remember, read some books.